Today we're going to learn about the problem solving step system for solving problems not just in math but also in life. And then we'll talk about how this system is used specifically to solve linear equations. Okay, so the first step in solving a problem is to identify what the problem is. You want to identify what the problem is. So for example, the other day when I was inputting grades for my students, I realized that many of the grades were a lot lower than they should have been. So the problem that I identified was that the grades are lower than they should have been. So this is the first step always when trying to solve a problem. You have to identify what the problem is. You got to know what it is. Once you know what it is, you can begin to break down the problem. So once I knew that the problem was students' grades are lower than they should be, I began to kind of think about why maybe they are that way. And one of the things that I came to was that students spend more time in class working on homework and less time in class working on their assessments. And because of that, they're not able to complete their assessments, therefore causing them to have a lower grade. So I began to break down that problem, and then I began to brainstorm ways to solve. Okay, so you want to break the problem down and then start brainstorming ways to potentially solve that problem. So what I decided was, if I make it so that students understand their homework a little bit better by providing them not only which questions they get wrong, but what the answers are to the problems that they're getting wrong, then maybe they can begin to spend more time in class doing quizzes because they're able to complete the homework at home because they understand how to input their answer now. So that's what the potential plan was. So the third step is to execute that. So I told the class, we're going to try this out and we're going to see how it works. So I unlocked all the homework so that they could see the answers. And I gave it enough time to see whether or not that was a good or that was a smart decision that I made, or if that was a dumb decision that I made. The fourth step is to review the decision. So was it a smart decision or was it a dumb decision? So what I did was I asked the class, hey guys, do you think this was a smart decision? Like, do you think this was helping you be more successful in terms of improving your grade, or do you think this isn't helping you improve your grade? Do you think this was a dumb decision? So we reviewed the plan to see whether or not it was a smart plan or a dumb plan, right? And the class decided that it was a smart plan, so we kept the plan. If the class had said, no, this was a dumb plan, this was a dumb decision, okay, then we would have gone back to the second step to brainstorm a different plan, right? In math, right, the first step is to identify the unknowns and the knowns. Okay, you want to figure out what the problem is asking you for. Those are going to be your unknowns. So they're asking you for something, that means you don't know them. And in math, we represent unknowns with variables. The most common ones, obviously, are x and y, but really any variable, okay, can be used. The second part of this is also to identify the knowns. So in math, when you read, a word problem, the knowns typically are values. Okay, if unknowns are variables, the knowns are values. So we want to identify what it's asking us for. Those will be our variables. And then we want to identify our values. And then our second step is going to be to determine what model and our plan for solving is. So with linear systems specifically, we've learned about two models. We've learned about slope-intercept, and we've learned about standard form. Slope-intercept was, or the model for slope-intercept, standard, is y equals mx plus b, where x and y are variables, things that are unknown. M is our slope, but we refer to this as our rate because it's getting multiplied to x. Rates get multiplied. And b represents our y-intercept, but it represents our starting value in word problems. So if we get some sort of word problem that talks about one rate and a starting value, then we know we're going to use slope-intercept, right? Standard form is ax plus by. equals c. In this form, we have two rates because there are two things being multiplied to each of our variables, right? We've got the rate that's being multiplied to our x, and we've got the rate that's being multiplied to our b. And then we have this c right here, and this c represents a constant. This is a constant. Well, it's a constant, meaning it's not a variable and it's not a coefficient. It's just a number, right? The c here is some sort of total. You can see that when you add ax plus by, you're going to get some sort of total that's given. It's a total that is given. This is different than this variable over here, where y equals, mx plus b. Y also represents a total, but this is a total that is not given because it's a variable. So when you're not given a total, sometimes you know that you need to, and you're asked to find the total, then you know you need to use slope-intercept form. When you're given a total, then you know that you should probably use standard form. Now, these aren't foolproof systems, right? You can use either model, but one model is more conducive to solving certain problems, and the other model is conducive to solving other types of problems. The third step is to execute the plan, so that's to use the algebra, okay, to either find x and y. And then the fourth part is to verify the solution as viable and put the solution back into context. So in the third part, we're using the algebra, using our properties and our mathematical tools to solve. And the fourth step is to take what we solved and from the algebra and put it back into the context. So we're not talking about x and y in the fourth step. We're converting our algebra to the real world. And discussing whether or not our solution is viable, right? Should we get a decimal? Should we not get a decimal? So these are the 4 steps to problem solving any type of problem, and then obviously specifically linear systems